Hello and welcome back to Quay Does Leetcode. Today I'm going to be doing problem 206, reverse a linked list. So this problem is pretty straightforward. You're given the head of a singly linked list and you need to return the reversed list. So you return the head of the reversed list. So if you're given a linked list that is 1, 2, 3, 4, 5, you return 5, 4, 3, 2, 1. So there are multiple ways to do this. You can do this iteratively and you can do it recursively, and I'm going to show you how to do it both ways. So first I'm going to show you how to do this iteratively. So if you're given a list, and let's just shorten it, make it 1, 2, 3, 4, and the last pointer, you know it's the end because it points to none. So how will you return 4, 3, 2, 1, and then have 1 point to none? How can you do this? Well, the first thing you need to do is you need to have you need to keep track of your current pointer. So you can loop over the list, and in order to get your current pointer, your current is going to start at head. So you have current equals head. And then you need to also keep track of your previous. So you're also going to keep track of what your previous, in order to reverse the list, you're going to have to make your previous pointer point to your current pointer point to your previous pointer. So you're going to have to keep track of a previous. In order to keep track of a previous, you have to have it start at null or none. So you can have a previous pointer starting at none. This is your previous pointer. And so you have a previous starting at none. And every time you move your current pointer, you're going to update, before you move your current pointer, you're going to update your previous to your current, and that's how you're going to keep track of your previous. So then you need to loop, and you're going to loop until you get to your end of your list. So you're going to loop while current is not equal to none. So this will loop until you get to your end of your list here. When you get here, it's going to stop. So the next thing you need to do is keep track of what your next pointer is, your next node. So this is what your next node is going to be. And you need to keep a variable for this because you're going to be updating your next pointer. Your next pointer, current.next, is going to be changed to your previous. That's how you reverse the list. But if you update current.next to previous, now you have no way to get to the next, move on to the next pointer. So if you save the next pointer, then you have access to it, so you can move your pointer. So you're going to save your next pointer. So current.next, you're going to have a next pointer, and your next is going to equal current.next. So now you've saved your next pointer, and this is next. This is current. And so now what you want to do is you want to change your current dot next to point to previous. So current dot next is equal to previous. So that is going to take one is you're going to take this current dot next is this pointer, and it's going to point to previous, and previous is none, so one is going to point to none. And then you already have your current dot next, your next pointer saved. So now you can move your current is going to be equal to next. So current is going to move to next, and well, before you move that, you're actually going to update previous. So your new previous is going to be current. So previous is going to move to the previous current, and current is going to move to the previous next. And then you're going to do the loop all over again. So you're going to continue doing that until you get to your current is none. So let's just continue doing that. So next is current dot next, and current dot next is previous. So 2, the next thing of 2 is 1, and then 1 all pointed to none. And so then your previous is going to be your current, and your current is going to equal your next. And now you're at the top of the while loop again. Now your current is not none, so you're going to go into your loop, and then you're going to do your next equals your current dot next. So this is going to be here, and then your previous is going to equal your current dot next is going to equal your previous. So current is 3, so current dot next is going to equal previous, so that's 2, and then that points to 1, and then none. So this is this is your previous right here, and that's your your previous is going to equal your current, and your current is going to equal your next, and your loop is going to loop again. Now your current is not none, so you're going to go into your loop, and your next is going to equal your current dot next. So this is going to be your next, which is none, and your current dot next, your current is 4, so it's going to point to its current dot next is going to point to your previous, which is 3, which points to 2, which points to 1, which points to none. And now your previous is going to equal your current, and your current is going to equal your next. And now your current is none, so we're going to stop the loop. And then at the end, all you need to do is return previous, because your previous is now here, which points at your head of your reverse list. So that is how you do it iteratively. So let's just type in this code. So this code that I wrote down here is essentially the code that you need for to solve the problem, but let's just type it in Leetcode. All right, so the first thing you need is a current pointer. So you're going to have your current pointer point to head. And then you need a previous pointer, and your previous is going to point to none. And now you're going to loop while your current does not equal none. And you're going to go into your loop. Then you're going to save a next pointer so that you don't lose what your next is. And your next is going to be current.next. Now you're going to update your current.next to your previous. And now you're going to keep track of your previous, which is going to be what your current is. So your new previous is your current, and your new next, your new current is going to be moved to what your old next was. So next. And then at the end, when all that's done, you want to return your previous. And that's the code. So let's run it. And it's giving us a correct reversed list. So let's submit it. And it is successfully submitted. So that's how you do the iterative version of reversing a linked list. Now let's move on to the recursive method. So to reverse a linked list recursively, first you need to consider what your base case is. So when would you know that you need to stop? Well, what is a reverse list? What is the simplest case of a reverse list? Well, if you get to your last node, one node is a reversal of itself. So you want to, your base case would be when you get to the end of the list. And the end of the list is the last node. So when your pointer is at the end of your list where its next is none, then you know you've gotten to the end of the list. So, okay, if you get to the end of the list, then that's a reversed list. So, what would you do if you were given a reversed list and you needed to, you were given the reversed list and now you need to, and your head is at the previous node. So how do you reverse that list? Given your reverse list is for a none, what you do is you make your head dot next your head. So you make your next node point to your head, and you make your head next point to none. So let's see what this is like written. So you're going to stop your recursion. You're going to keep passing your next node into your recursion until you get to your base case, which is your head.next is none. So we're going to say if there's only if there's nothing to reverse, meaning your head is none. So you're not going to do a while. You're going to we're going to call this function def reverse list. And we give it a head. And if our head is none, then that means there's nothing to reverse. Or if our head dot next is none, then we return head. Because if we're on this last node, a reversed list of that is just itself. And so that is what we return if we are given this this case. And if we're given just a list with nothing in it, then we just want to return none, which is our head. So then if that's not the case, we need to do the recursion. So we're going to keep calling this function. So we're going to get our reversed list, and we're going to call this function that will give us our reversed list. So we're going to give it, and as our head, we're going to give it the next node, head.next. So we're going to call reversed list given head.next. Now we have a reversed list. So we are going to, so if we start at 1, we're going to check, is this head none? Is head.next none? No, the head is 1 and the head.next is 2, so neither of them are none. So we're going to go into our recursion and we're going to give it head.next. So head is here. Now we're going to call this function and we're going to give it head.next. So our new head is here. And so then we're going to check, is head none? No, it's 2. Is head.next none? No, it's 3. So we're going to give it head.next. Now our new head is here. Now we're going to check, is head.next, is head none? No, it's 3. Is head.next none? No, it's 4. So we're going to give it our head.next as our new head. So head is here. So now head is not none, but head.next is none. So now reversed list is going to be returned as head. So reversed list is going to be 4, and that points to none. Now we have our reversed list. So now what are we going to do? We need to So it returns this, and now we're back at head is 3. And so what we need to do is we need to reverse our 3. And so we do head dot next. Head dot next is 4, and its dot next, we're going to change that to head. So we're going to make that point to 3. So we're going to reverse that. So head dot next is going to point to 3, and then we're going to point head dot next is going to point to head, and then head dot next needs to point to none. So this is head is 3 still, and head dot next needs to point to none. And then we return our reversed list. So now our reversed list is this, and our new head is 2. So now our head dot next, that's 2, and the arrow is the dot next, and that its dot next, head dot next is 3, and its dot next needs to point to So head is 2, and head dot next is 3. So 3's dot next needs to point to head. So head is 2, and it points to 2. And the 4 already pointed to 3, and then you make the head dot next, which is 2, point to none. Now our head is 1. So its dot next, head dot next is 2, its dot next, now we are calling reversed list again, and we're giving this reversed list everything else that was reversed as reversed list. And head 1 is our new head. So its dot next, which is 2, needs to point to itself, which is 1. So it was already having all these other pointers before it. So its dot next is going to be head, which is 1. And then we're going to set head dot next, which is 1, to, it's head dot next, head dot next is going to be none. And then we return the reverse list. And this is the last thing in our reverse list. So we return 4, 3, 2, 1, none. And that's how you do it. So let's type this into Leetcode. Basically, this is the code, but let's just type it in. Okay, so the first thing that you do is take care of your base case. So if head equals none, or head dot next equals none, then you just run a return head because you're at the last node, or there was no nodes. So you return head. if there's still, so you're at the last node. So if you're at the last node, and a reverse list is just itself, then you want to get the reversed list, and that's going to be by calling the function reverse list and giving it head.next. Then once you have your reverse list, you need to reverse the current node that you're on by setting its next node, its next. So head.next equals the node that you're currently on. So you point its next, head.next is next to head. And then you need to point your head.next to none. And once you do that, you can just return the whole list, the whole reverse list, because now the whole thing is reversed. And that's how you do it recursively. So let's run this. So it's reversed correctly. Let's submit. So it was accepted, and that's how you reverse a linked list recursively. So the time complexity for the iterative version and the recursive version is going to be O of n, because you have to visit each node once. And the space complexity for reversing iteratively is going to be O of 1 constant space, because you only need some pointers which don't increase as your n increases. They just stay the same because they're just pointers. So that's going to be constant space. But for your recursive space complexity, it's your stack, your recursive stack is going to be building up. And so your space is going to be O of n space complexity. And I hope that was helpful. Thanks for watching, and I'll see you in the next video.